then like 6 months before.
Exactly. Too warm in here.
Because I'm here.
Do you know what this means?
I'm sorry.
Do you know what this means?
Yeah,
Do you know the meaning of this? Okay.
I know.
Do you know this meaning? Oh, good. Do you know this meaning? Right, let's have a look. Do you have the question there?
Yes.
Okay, so what's the first one?
A diffraction graphing has 300,000 lines per meter.
Okay, so the first part, you're told it has 300,000 lines per meter. Yeah? Okay, what's the first question?
Red light with wavelength 633 nanometer is incident.
Yeah.
Normally on the graphing, which is 1 meter from a screen. A. Determine the line spacing. B.
Okay, so first we want to calculate D. So what you have here is 300,000 lines per meter. So the distance between...
It's missing. We also have the D. Big D.
633.
No, this is the small d, and the big D is 1 meter.
The wavelength is 636.
Okay.
Wait, it's the same question, big D only.
Doesn't it?
Does it?
You just...
What?
Big D.
Yeah, it has
A.
D.
Determine the line spacing.
Yeah, but in the question it said it's 1 meter from the screen.
Yeah.
Oh, okay.
Yes,
okay,
it's 1 meter from a screen. Yeah.
Okay, so this is the small d. Yeah?
Why D?
Yeah, well let me just put it this...
What is that formula?
It's not a formula, it's an idea. So, for example, if this is 1 meter, yes, and I have one line, then what's the distance between the lines? 0.5. Now let's say it's like this. What's the distance? 25. So if I have 300,000 lines, then the distance would be 1 meter divided by 300,000. Ah, now it makes sense. Is it okay?
So it will be 3.23 multiplied 10 minus 6.
Think so? What's
Yeah.
10 minus 6?
10.
Yeah, what prefix? No, you won't, no, don't tell her. You know it?
I'm not saying anything.
Yeah, good.
Minus 6.
Don't say anything. What is it? Something meter?
Multiply 10.
Yeah, what's it called? That's 10 power. 10 power minus 6. But what is it called? 10 minus 6?
Up.
No. What is it, do you know? DC. What the heck are you talking about? Ehud?
Really? What?
Minus 6? Not maybe.
Minus 6.
Millimeter square.
Micro? No.
Micro!
Oh, so you asked that.
Yes.
I think you asked
No.
what is minus 6.
I know what is minus 6. I want to know its name.
Yeah, I think you asked me the name of the
Oh,
minus 6.
okay, misunderstood.
Oh,
Misunderstood.
Okay. All good? Yeah. Is it 10? Is it minus 6 here?
Yeah.
You worked it out? Okay.
I think 300,000 is T. So I calculate the F.
Oh my
So
goodness.
it's same.
That was just an accident. That's totally wrong. Okay, is that part A?
Yes.
What's part B now?
Determine the diffraction angle for the second order of wavelength.
Okay, so you have n lambda equals d sine theta. So 2 times 633 times 10 to the minus 9 equals 3.33 times 10 to the minus 6 sine theta. So theta equals.
N equals 2.
Yeah, it said in the question the second order.
Oh my god, okay.
Yeah.
And the order. It says in the question, I didn't get it.
22.3 degrees.
C, determine the highest order diffraction line that is observable for the
Okay.
light.
So we remember n lambda must be less than d sine 90. So in other words, n lambda must be less than d. In other words, n must be less than d over lambda. D is 3.33 times 10 to the minus 6, and lambda is 633 nano. So you get n must be less than 5.26. So the maximum it can be is 5 orders. Yeah. Okay. D.
The red light is replaced by a blue light of wavelength 506.4 nanometer, and it is found that the diffraction angle for some order of the red light
Coincides.
coincides exactly with the diffraction angle for the blue light in the next order spectrum. Determine the order of the spectrum for the blue light, hence use x and x plus 1 for the order n.
Sit there. No, you're going to sit there, and you can take your stuff. Yes. Okay. So this D one is a little tricky. How much more is after D?
E, F, G, H.
Oh man. All right. D now. Mahmoud, would you hurry up? Okay. Great. Perfect. Good job. Okay. So listen again. Adnan is going to read through it and we'll write the information down. So just go bit by bit. So firstly,
The red light is replaced by blue light of wavelength 506.4 nanometer.
okay, so you had red light previously, and the red light, it had the different orders like this, and then this gets replaced with blue light. Maybe I should have done this in red, but it doesn't matter. So this is red, and it will be here, 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 and here, and then you replace this with blue light, which has a different wavelength, so it will have different angles. Yeah. Okay.
Wavelength, the blue light is 506.4.
Mhm.
And it is found that the diffraction angle for some order of the red light
Coincides
what does it?
in the same place.
Coincides exactly with the diffraction angle of the blue light and the next order spectrum.
Right, so what I was saying here was, for example, this one here, n equals 0, n equals 1, n equals 2. So,
down one is
minus 1, minus 2. Now, the blue light will be at a different angle, so, it'll come out here instead. Maybe this is n equals 1 for the blue light. Something like this. Now, in the question, just read that part again that says coincides. So just before that, it is found that
It's found that the diffraction angle for some order of the red light.
Pause. So for some order of the red light, yeah, continue.
Coincides exactly with the diffraction angle for the blue light in the next order.
In the next order, right. So for some of the order of the red light, like for example n equals 2, this coincides with the next order in the blue light. So what I'm saying is, maybe the blue light matches where the red light is in n equals 3. Yeah. So that doesn't mean that they match with the other ones, of course. So maybe n equals 2 could be like here, and n equals 1 could be like here. But what I'm saying is, for for one of the orders of the red, it matches with the next order in the blue. So my hint was, you call the order for the X, the N, the order for the red X and the order for the blue X plus 1. And you don't know when this coincides, what would be the word? Coincides.
C-O-I-N.
Oh no, I know the word coincide. I'm trying to make it,
A noun?
yeah. Coincidence? I don't know. Location. So we don't know where this location is. Alright, so can we start this now? Can we see how to do it? Yes? Are you looking up to see if there's a noun for it?
What's determine the order of the spectrum?
Yeah, find the X. Okay, so let's have a look here. So you know, for the red light, you have n lambda for red equals d sine theta. And then for the blue light at this place where they coincide, you have n lambda for the blue light equals d sine theta. The d and the sine thetas are the same. It's the same angle and the same d. Although the n is not the same.
Yeah.
This n is actually x,
This has,
and this n is x plus 1. Yes?
what about 506.4?
Yeah, so that 506.4, that's here. And the red one was 633, wasn't it? Now,
633 is.
because this equals d sine and this equals d sine, we can say x, yeah, x wavelength of red light equals x plus 1 wavelength of blue light. What did I say the wavelength of the red one was? 633, wasn't it? Nano.
633.
And then for the blue one, it was
506.4.
nano, wasn't it?
Yes.
So I can cancel nanos on both sides, and I'm left with 633x equals 506x plus 506. Yeah. Is that okay?
Okay.
Yeah. So we get 127x equals 506. And that comes in at x equals 4, or 3.98, so 4 then. So what that means is that when you look at the n equals 4 for red light, that would be in the exact same spot as the n equals 5 for blue light. So they coincide there. Now that was the hardest question for this I've seen in the exam, this coinciding business. And he's asked this question twice. So if you're asked it again, you know how to deal with it. You have an x and an x plus 1 then, and now it's not so bad. Yeah, so it's not so bad.
Yeah.
Alright, what's the next part, Adnan?
Determine the diffraction
A,
angle.
E, yeah.
Determine the diffraction angle for the second order of blue light.
Oh, that's so easy. Right, so n is 2. Lambda for the blue light is, what did I say, 607 point...
506.4.
506.4 nano,
Yes.
and then that equals d, which is still 3.33 times 10 to the minus 6 sine theta. Oh, we did one like this earlier. Why did I ask it again? 506.4 times... Oh, do you know why? I probably pulled all of this from an exam question. Okay. Times 506.4 times 2 times 10 to the minus 9 divided by that. And then sine inverse. And I get theta is 17.7 degrees. Okay, what's next?
The fringes were red in part A, and then of course blue in part D. If the blue light was replaced by white light, what color would the fringes be?
Okay, so,
Hence answer B and E will help.
yeah, so the second order for the blue light, I just did it here, that's at an angle of 17.7 degrees. So this color here is blue. What was the angle for the second order of red light?
22.3.
Yeah, I wrote it down, but where did I write it down? 22.3, yeah. So for the red light, the second order will be a little bit higher at 22. The red light will be here. So if you were looking, the colour here will be red, and then underneath it would be blue, and this is at the second order. Now if I replace this with white light has all the colours in it. Red, orange, yellow, green, blue, indigo, violet. And you can see here you have red and here is blue. So what's going to happen is you'll get all the colours here, but the order will be the red one on the top, and as we change the wavelength we move through the list. So for example, red, hang on, don't confuse me, what was red's wavelength? 633, and blue was?
506.
Yeah, so as we go down the wavelength gets smaller, and the smaller wavelength made a smaller angle. You see the red has a bigger angle than the blue. So for example, there's the blue, so the green will be in between, the wavelength will be in between the red and the blue, so it means the angle is in between as well, so in the middle here would be green. So in other words, what would you see here if you looked at the screen? N equals 2, you would see a rainbow.
Is it like a repeated thing?
No, just one colour each, yeah, red, orange, yellow, green, blue, indigo, violet. So it'll be like little rainbows where the orders are.
So like small rainbows, a lot of rainbows.
No, like if you were looking at the screen, okay, in the middle is n equals 0,
Okay.
and then here is n equals 1 and n equals minus 1, if you're looking straight at it. So what I'm saying here is you'll get red, orange, yellow, green, blue, indigo, violet spread out here. And I think, I don't know actually about the center one. And then for the other one here, I think it'll be the same, red, orange, yellow, green, blue, indigo, violet. I think it's symmetric.
But why do we have the dark place?
Huh?
Isn't it like all the way blank?
What are you asking me exactly?
Because it's white light, right?
Yeah, so white light has all the colours in it, and when it hits the diffraction grey and the colours get separated to different angles because they are different wavelengths. So the white light gets split, is what's happening here.
But why do we get like the uncolored areas?
Uncoloured areas, like here.
Yeah.
But this was everything we were
No, but I'm saying like there are a lot of wavelengths.
I know, but not enough to fill in all of this completely. Because there are some colours of light you cannot see with your eyes, like ultraviolet.
Yeah.
So after violet will be ultraviolet, but we cannot see that.
There is ultraviolet, but we can see.
Yeah, but the white light wouldn't have ultraviolet in it unless it came from the sun. You know, so it's dark because there's not enough wavelengths. Yeah, is it okay? Are you sure? It'll have to be okay. Right, G. What's G?
What is the French spacing for red light?
Okay, so we have the other formula, what was it? S equals, hang on, let me see if I remember. Lambda, which is small, big D over small d. No, small d over big D.
No, big D over small d.
Are you sure?
Yeah.
Sure?
Yeah.
Okay.
You
Right.
don't trust me.
And I do trust you completely. What colour light is this, red or blue?
Red light.
Red light, so that was 633 times 10 to the minus 9 times 1 over 3.33 times 10 to the minus 6. So the space in between the fringes . Oh, I must have did something wrong there. Yeah, that's better. 19 centimeters. Okay, what's next?
How wide does the screen need to be?
Okay, so the screen here What's the maximum order? Do you remember? It goes as far as 5, and then here will be minus 5. And the spacing between the orders is 19. So you would need to be using a 1.9 meter screen, 10 times 19 centimeters. No? Yes? Yeah. Yeah. Anything else?
No.
The good thing about this is this could be a section B question. And when you think about it, okay, some parts were difficult to understand, but how many formulas were you using for this whole question? Just 2. This one and the other one with the theta in it. So I kind of like this one in the exam. It comes up from time to time, maybe every 2 years. I think it's a good section B question. What confuses students in it is the English when they're reading it. Yes?
Yeah,
True? True. Okay, will we go on to the last topic then for semester 1? Yes, I can close this? Yep. Okay.